This video is integrated to math analysis. It's the review for second semester called Amazing Algebra. So on this first problem, they want us to put this in vertex form. So we are going to complete the square. So we are going to, I'm going to subtract the 3. And then I want to figure out x squared minus 4x plus what? So what we're going to do is we are going to take this -4, which is our b, and we're going to take half of it. So we're going to take -4 divided by 2, which is -2. And then we're going to take -2 squared, which is 4. So you basically take your b divided by 2 and square it. And that's what you're going to add to both sides. So I'm going to have y minus 3 is equal to x squared minus 4x. And again, when I took half of my -4, which is -2, and squared that, I got a +4. And then this is going to become y plus 1 is equal to, and this is x minus 2 squared. I am going to -1 from both sides, and I get x minus 2 squared minus 1. And that's your equation in vertex form. On number 2, we're solving this. This is actually in the nice completed square form. So we're going to take the square root of both sides. So I'm going to have x plus 16 is equal to plus or minus 3 when I square root both sides. And I'm going to get x is equal to -16 plus or minus 3. And so I'm going to get two answers. One's going to be -16 plus 3, which is -13. And the other one is going to be -16 minus 3, which is -19. And those are our two answers. On number 3, this is using laws of exponents. So everything in that parenthesis, since it is a monomial, single term, is being raised to the power 3. So 3 to the 3rd, and then my y to the 4th is being raised to the power 3. My m to the 5th is being raised to the power 3. And so 3 to the 3rd is 27. When I have power to power, I multiply. So I'm going to get y to the 12th, m to the 15th, and that's your answer. On number 4, so we want to write the equation of a circle with the center of -3, 1 and a radius of 5. And the equation of a circle is x minus h squared plus y minus k squared equals your radius squared. So I'm going to have, because of the -3, x plus 3 squared. Anytime it's in parentheses, it's going to be opposite. And my y is a 1, so this is going to be y minus 1 squared. And then 5 squared, which is 25. And that is our answer. On number 5, we want to find the inverse. Inverse is when you switch your x and y. So you can think of this as y equals 2x minus 5. And then I'm going to switch my x and y. So I'm going to get x is equal to 2y minus 5. And then you want to get into y form. So I'm going to add 5 to both sides. And I'm going to divide by 2. So x plus 5 divided by 2 is equal to y. Or 1/2 x plus 5/2, if you want to split it, is equal to y. On number 6, we are multiplying out these complex numbers. So you might want to do it in a box. 2 and a -3i, 3 and a -4i. So 3 times 2 is 6. 3 times a -3i is a -9i. 2 times a -4i is a -8i. And a negative times a negative is a positive. So I'm going to get a positive 12i squared. Now, one thing to remember. I, remember, is equal to the square root of a -1, which means I squared, if I square both sides, is equal to a -1. So every time you see an I squared, you're going to give me a -1. So what that means is this right here is really 12 times a -1 or a -12. Okay. So when I add all of this up, I'm going to have my, I'm really going to have, this is going to become a negative 12. So I'm going to get negative 6 minus 17i as my answer. On number 7, we're solving this system. They want the x coordinate. So I'm going to use elimination. Since we want the x, I'm actually going to eliminate my y in this case. So I'm going to multiply this one by 3 and this one by actually 2. I just need to make it multiply by a positive 2. So I'm going to get 9x minus 6y equals 9. I'm going to get negative 10x plus 6y, and that was my goal, is to get my y's to be the same but different signs, is equal to negative 2. I'm going to add these equations together. I get negative x is equal to 7, so x is equal to negative 7. Now, that's what they wanted, but if they had asked you to solve the system, I then would have taken this and substituted it into one of the equations. So let's say I do it into the second one. Negative 5 times negative 7 plus 3y equals negative 1. I would have gotten 35 plus 3y is equal to negative 1. So I get 3y is equal to negative 36. So y is equal to negative 12. So again, they wanted the x coordinate, which is negative 7. But if they had asked you to solve the system, it would have been negative 7, negative 12. Okay, on number 8, I'm going to factor. So we can do a box to diamond. So I'm going to put my 5x squared here and my negative 2 here. Those multiply to a negative 10x squared and have to add to this negative 3x here. And so what multiplies to negative 10x squared and a negative 3 adds to a negative 3x? Well, that's going to be a negative 5x and a positive 2x. So I'm going to write negative 5x, positive 2x. Doesn't matter which one I write where. But now that I've written that, my outside will be determined. 5x is going to go here. X times 2, 5x times a negative 1. So my factors are going to be 5x plus 2 times x minus 1. On number 9, we're going to solve this. So first thing I'm going to do is I'm going to rewrite it with 0 on the other side. And then I'm going to factor this. So I'm going to have a 6x squared, zoom in a little bit. I'm going to have a 6x squared, a negative 3, which is going to be a negative 18x squared. I need to get a 7x, so that's going to be a 9x and a negative 2x. So 9x, negative 2x. When I find the outside, so I'm going to have a 2x here and a 3x here. 2x times negative 1, 3x times 3. So my factors are going to be 3x minus 1 times 2x plus 3 is greater than or equal to 0. If I find my boundary values for this, this is going to be x is equal to 1/3. That's where it would equal 0. And this would be x is equal to negative 3/2. So the way I like to think about this is, let me put on my negative 3/2 and my 1/3. These are where it equals, okay, where it equals. So these are going to be solid because that makes it equal. And then we need to decide if we're going to shade in between or outside. The way I like to think about this is a positive parabola. And I basically want to know, where is it greater than or equal to 0? Basically, where's it above the x-axis? So these 2 points that are on the number line would be your x-intercepts. So I'm going to graph this in green. This would be an open up parabola that would be having x-intercepts at negative 3/2 and 1/3, which means in between negative 3/2 and 1/3, it's going to be below or less than 0. Outside of negative 3/2 and 1/3, it's going to be above or greater than 0. And we want it to be greater than or equal to. And so we're going to be shading outside. And again, it's because this is a positive parabola. These would be where it equals 0, these two values. So that would be where it's on the x-axis. So if I was just to sketch a open up parabola, okay, going through these 2 points for the x-intercepts, I'm greater because I'm above 0. I'm at 0. I'm below 0 here. I'm at 0. I'm above 0. So here I'm greater than 0. Here I'm greater than 0. That would be your graph. And the way you're going to write your answer when you have 2 separate pieces, x is less than or equal to -3/2, or, that word or, x is greater than or equal to 1/3. And that would be our answer. On number 10, finding x-intercepts, we want to know where this equals 0. So 0 equals x squared minus 8x plus 7. I'm going to factor that. I basically want to know what multiplies to 7 and adds to -8. So that is going to be a -1 and a -7. So this is going to be an x minus 1, x minus 7, which means my x-intercepts are going to be at 1 and 7. On 11, we're solving this equation. We want to get rid of all my denominators. So I have a 3, a 4, a 2, and a 12. I want to multiply by something that gets rid of all 4 of those. So I'm going to multiply everything by 12. So I'm going to go 12 times 2/3 x minus 12 times 3/4 equals 12 times 1/2 plus 12 times 11/12 x. And what's going to happen here is the 3 goes into the 12 6 times. Sorry, 3 goes into 12 4 times. 4 times 2x is 8x. 4 goes into 12 3 times. -3 times 3 is -9. 2 goes into 12 6 times, so I get a 6. 12 goes into 12 once, so I'm going to be left with that 11x, and now I'm going to solve this. I am going to minus 8x from both sides. So I'm going to get -9 is equal to 6 plus 3x. I'm going to minus 6. So I get -15 is equal to 3x. So when I divide by 3, I get x is equal to -5. On number 12, I'm going to do a similar process here. Okay, so I have a 3, a 6, and a 2. I'm going to multiply everything by 6. So I'm going to go 6 times 1/3 x minus 6 times 4 equals 6 times 5 6x plus 6 times 1/2. Okay, so 3 goes into 6 twice, and I multiply and I get a 2x. Here, the 6 and the 4, that's going to be a 24. You have to multiply everything, even though that did not have a denominator. Every term on both sides has to be multiplied. 6 goes into 6 once, and I get a 5x. 2 goes into 6 3 times, and I get a plus 3, and I'm solving this. So I'm going to minus 2x from both sides. So I'm going to get -24 equals 3x plus 3. I'm going to minus 3 from both sides. So I get a -27 is equal to 3x. I divide by 3, and I get -9 is equal to x. On this one, identify the vertex of the given parabola and then sketch it. So this vertex is going to be 0, 1. That is going to be my vertex. And so if I'm sketching this, I am going to go to 0, 1. Okay, so 0, 1. And then from there, if I go out 1, because this parabola is just a regular parabola, so I'm just graphing plain old x squared here. So if I go out 1, 1 squared is 1. So I'm going to go up 1. So I'm going to be here at a height of 2, and it's going to be the same on the other side. And from my vertex, if I go out 1, 2, 2 squared is 4. So I'm going to go up 4, 1, 2, 3, 4, and so on. And there is my parabola. On number 14, identify the vertex and then sketch it. So the vertex for this one is going to be 3, negative 2, because whatever makes this 0 is your x, and then whatever this is, that is your y. I don't have any stretch besides just a normal 1 being in front, so it's going to be a regular parabola at 3, negative 2. Okay. So 1, 2, 3, 4, 5, 1, 2, 1, 2, 3, 4. Yeah, let's get a couple of these. Okay. So I'm going to plot 3, negative 2. So 3, negative 2 is down here. This is an open up parabola. And now from here, I am going to go over 1. 1 squared is 1. So I'm going to go up here, and it's going to be the same on both sides. If I go from my vertex out 1, 2, 2 squared is 4. So I'm going to go up 1, 2, 3, 4. And so on. And there's my parabola. On number 15, tell whether the graph opens up or down, whether the graph is wider, narrower, or the same as the graph of f of x equals x squared. So the negative is going to make it open down. So that's gone, that's gone, that's gone. The 1/2 is going to make it wider because everything's half as high. So it's going to make it fatter. So when your a in absolute value is between 0 and 1, it's wider. And when your a in absolute value is greater than 1, it is narrower. And if your a is 1, then it remains the same. So in this case, it's going to be down and wider. So that's A. On number 16, similar idea, want to compare it to plain old x squared. So what the -1 does, it's going to drop it down. So it's going to go down 1. Everything else stays the same. It's still going to open up. So all these open downs are gone because it's going to open up because this is positive. And there's not a number in front, so it's not going to be wider or narrower. And again, that -1 just drops graph down, drops graph down 1 unit. They actually didn't care about that looking at the responses. So this would just be an open up parabola that got moved down 1. There's no number in front for your A besides 1, so it's going to be up and the same. And that's the end of this review worksheet.